Good morning and welcome to TT in the Morning. I'm Trevor Wyand.
And I'm Tommy Ayers. And here is your news.
Today we're going to talk to you about what is a mole.
Everyone knows that a dozen represents 12 eggs or donuts. The mole is similar to a dozen because the mole will always equal 6.02 times 10 to the 23rd items. However, the items we are talking about are much smaller than eggs or donuts. We are talking about particles.
In terms of particles, 1 mole equals 6.02 times 10 to the 23rd, or Avogadro's number. For example, in 1 mole of carbon, there are 6.02 times 10 to the 23rd particles. And also, in 1 mole of hydrogen, there are 6.02 times 10 to the 23rd particles.
And here's Tommy in the field. So in order to convert from moles to representative particles, all you do is multiply the moles of what element you have, and in this case it's carbon, by Avogadro's number, which is 6.02 times 10 to the 23rd particles. And then you get your answer of 6.02 times 10 to the 23rd particles of carbon.
Thanks, Tommy.
To demonstrate how big 6.02 times 10 to the 23rd really is, here's Trevor with an example.
If you had a mole of sand, you'd have more sand than on the entire Miami Beach.
Thanks, Trevor. Think how difficult it would be to count all those grains of sand without using the mole.
That would be pretty hard.
You think?
Here's another example with Tommy on how big the mole is.
If you had a mole of pennies, you evenly distributed the pennies to everyone in the world, you would be giving every single person in the world $1 trillion. That is more money than Bill Gates has.
Thanks, Tommy. That is a lot of money.
Yeah, that is. 1 mole of any gas, like H2 or O2, will always have a volume of 22.4 liters at STP, or at 0 degrees Celsius and at sea level air pressure. Here's Tommy with an example. In this example, we're trying to convert moles of hydrogen gas into liters of hydrogen gas. So what you do is multiply the moles of hydrogen gas by the conversion factor, which is 22.4 liters of H2 over 1 mole of H2, and the final answer is 22.4 liters of H2.
Thanks, Tommy. Mass in grams of 1 mole of any substance is equal to its atomic mass in grams. Here's Trevor with another example. In this example, we are trying to convert 1 mole of oxygen into grams of oxygen. To do that, you multiply 1 mole of oxygen times 15.99 grams of oxygen, which is the atomic mass. By dividing it by 1 mole of oxygen, it cancels out the moles, giving you an answer of 15.99 grams of oxygen.
Thanks, Trevor. The mole is important because it acts like a bridge between the 3 units of measurements: grams, liters, and particles. Here's an example problem that shows how the mole can be used as a conversion factor. Here's Trevor.
In this example, we're trying to figure out how many representative particles are in 15.99 grams of oxygen. To do that, you start with 15.99 grams of oxygen and multiply it by 1 mole of oxygen. By dividing it by 15.99 grams of oxygen, it cancels out the grams, giving you 1 mole of oxygen. Now, you take the 1 mole of oxygen and multiply it by 22.4 liters of oxygen and divide it by 1 mole of oxygen. As before, the moles of cancel out and you're left with 22.4 liters of oxygen. Now, you take the 22.4 liters of oxygen and multiply by 1 mole of oxygen and divide it by 22.4 liters of oxygen. And as we said before, the 22.4 liters cancels out and you're left with 1 mole of oxygen. Now, you take the 1 mole of oxygen and multiply it by 6.02 times 10 to the 23rd representative particles of oxygen and divide it by 1 mole of oxygen, leaving you with 6.02 times 10 to the 23rd oxygen particles because the moles cancel out.
Thanks, Trevor. The mole is an essential tool in chemistry because it allows you to process a lot of atoms with just a simple conversion factor.
It also is a very easy way to convert between liters, grams, and particles. This is Tea in the Morning. I'm Trevor Wyand.
And I'm Tommy Ayers.